Okay, what's the largest area I can enclose with 50 inches of string? That's the perimeter. That's P equal to 2x plus 2y because it's a rectangle. That's 50 equal to 2x plus 2y. That tells me that x plus y is equal to 25. So y is 25 minus x. I know the area of a rectangle is x times y. Now I just have one variable to look at. I can determine the vertex for this, and the vertex y value, the k, ends up being 156.25. So that's the maximum area. Okay, next up I have these absolute value inequalities. I'm not going to do all of them. I'm just going to do one of them, and I'll stick with this one right here. Okay, so when you're solving these, you want to remember that you have the standard inequality like this, and then you have the opposite inequality like this. And so we're going to solve each of these inequalities. Oh, and when I have the opposite, sorry, I need to flip the inequality symbol. Okay, so I got the opposite, I flipped the inequality symbol, and I solved these. So I got negative 4 is greater than or equal to 3x in this case. So I have x is less than or equal to 4 thirds, negative 4 thirds. And then on this bottom one, I got negative 1 plus 2x is less than or equal to x plus 5. That's x is less than or equal to 6. Okay, so I got x greater than or equal to 6. So I have two intervals here. I got negative infinity up to negative 4 thirds. And then I also have, oh, they should be brackets there, 6 to infinity there. Okay, there's the other solutions for those ones there too. Okay, now we need to complete the prompts. The degree of this one, the highest exponent I see is 9. How many terms are there? 3. That's a trinomial, if you want to call it that. The end behavior, n is odd and a is positive, so it's down and up. The domain, because it's a polynomial, is all real numbers. And then same thing for this one, all real numbers. Similarly over here, it's 8th degree. There's 3 terms, so it's a trinomial again. This one's going to be up and up because x to the 8th power, n is even, a is positive. Same domain. The range is going to be a little bit challenging, so don't worry too much about it. This one has an up and up, which means that a has to be positive and n has to be even. This one has an up and down, which means that a has to be negative and n has to be odd. All right, how many local extrema can a polynomial of degree n have? How few local extrema can it have? All right, so you want to think about a linear function. It actually doesn't have any extrema at all, correct? There's no max or minimum, so it could have 0, but you'll notice that it's actually n minus 1, because a second degree has 1, a third degree can have at most 2, so on and so forth. Could a polynomial have 2 local max but no local min? That would not occur, because if it has a maximum, it's going to have to turn somewhere, so it needs 2 direction changes. So that can't occur. No. And can it have local extrema without having any real zeros? Yeah, for sure. Think about a polynomial function like x squared that's been shifted up. It has local extrema, but it doesn't have any real zeros. Okay, here we have 2 division questions. I'm going to do synthetic over here because I have a linear divisor. Okay, so that means that I have x minus 3, and I have started with x squared, so now I have 4x plus 15, and then it's plus 44 over x minus 3 is how you want to write it. And then over here, I got x squared plus x plus 1 divided by 2x cubed plus 0x squared minus x plus 1. Okay, what times x squared gives me 2x cubed? That's going to be 2x. I distribute that out. 2x squared, plus 2x squared plus 2x. I subtract everything. That gives me negative 2x squared minus 3x plus 1. Here I got negative 2. That's negative 2x squared, negative 2x and minus 2. I subtract that. That's negative 3 plus 2, so that's negative x. And that's 1 plus 2, so that's plus 3. I got plus 1's cool, and then I have minus 2, so that becomes positive. Great. Okay, so now here I have x squared plus x plus 1 times 2x minus 2 plus this little remainder, negative x plus 3, all over x squared plus x plus 1. Because what's happening is I'm going to distribute this out, and when I distribute this out, it's going to be chill there, but this little term, these will cancel out, and I just have the remainder left over like we saw when we did the division. Okay, we have a remainder theorem question, so let's evaluate it at 2. Whoops, I have 4x negative 8. 3, 6, 0, 0, 4, 8, 0. Okay, so I got 0 here, so that means that it is a 0, and it tells me if it's a 0, you better factor it. That's x minus 2 times 3x squared plus 4 equal to 0. Now, if we look at 3x squared plus 4, we actually can't, oh, actually it doesn't really tell you to factor, it just tells you to write what's left, and so that's what we did. But if you're trying to figure out the solutions for that, it's actually only going to have complex solutions, and we'll talk about that when we get to next week with the complex number theorem. All right. Okay, we're given that 1/2 is a 0 of multiplicity 2, so I'm going to go through this 0 process twice. 4, 2, negative 26, negative 13, 48, 24, 18, negative 9, 0. And then I'm going to do 1/2 again. 4, 2, negative 24, negative 12, 36, 18, 0, 0, 0. Perfect. All right. I just said that I divided it by 1/2 twice, and then what's left? That's 4x squared minus 24x plus 36. I should recognize that I can factor a GCF out of that. And then I should also recognize that's a perfect square trinomial. So this one actually factors to x minus 1/2 squared, there's the 0 of multiplicity 2, times x minus 3 squared. Over here, this one is just a conjugate root theorem. 1 minus root 3, 1 plus root 3. Okay, give me a polynomial with zeros 1, 3. So 0 of 1, 0 of 3, multiplicity 2. First coefficient has to be negative 5. Down here they want it to be degree 4, and they want it to have a down behavior. That's going to be negative x to the 4th. And then on the last one, we have x equals 3 plus or minus square root 19 all over, 29, all over 5. You should recognize this as the quadratic formula. And so that means that b in this case is 3, because the opposite of b is, 3. It's not negative, is it? Yeah, 3. So now it's negative 3. I can also see that the denominator is 2a, which is equal to 5 in this case, so a is 5 over 2. So I have a and b. Now I can get c by looking at b squared minus 4ac. I know it's equal to 29. So I set it equal to 29, and I'll input all my values. 4, 5 over 2 times c, 29. That's 9. That's minus 10c is equal to 29. That makes negative 10c 20, and that makes c equal to 2. Sorry, that makes c negative 2. So now my quadratic is ax squared, 5 over 2x squared, minus 3x, minus 2, which you'll notice that they want it to be integer coefficients, so multiply the whole thing by 2. And now I have 5x squared minus 6x minus 4.